Right, we're going to look at the ambiguous case here. Two angles in one side determine a unique triangle. However, if two sides and one opposite angle are given, then three possible situations can occur. This is known as the ambiguous case. The three possible solutions are: number one, no such triangle exists. Number two, one such triangle exists. And number three, two distinct triangles exist. In each case, we're going to consider a triangle in which side A, side B, and angle A are given. For the no such triangle exists, notice the two situations here. A is acute, but A is less than the height of that triangle. Right? And so I give you an example of that. The second situation is that A is obtuse, and when A is obtuse, you know that, notice that third side can't reach the first side. I'd be good if I spelled obtuse right. Okay. And so A is less than or equal to B, so no solution. Right? One such triangle exists. A is acute, H equals B sine of A. All right, the first situation is a right triangle. We'll skip it. We'll use the law of sines to solve the other two cases. Right? So we will need to do first example. A is 76 degrees. Side A is 34. B is 21. We have an SSA. A is greater than or equal to B, so one triangle exists. We go for the good old law of sines, and when we go for the law of sines, we find that B is 36.8. So we can always find C real easy by subtracting those two from 180. Now we'll use the law of sines to find that third side, and use your calculator, and you will get that C is 32.3 in length. All right, let's do another example. A is 120 degrees. Side A is 25, B is 24. A is obtuse. A is greater than B, so one triangle exists. Notice the side opposite the angle is longer than the second side given. So we find angle B. Once we know angle B, we can find angle C very easily by subtracting the two from 180. Then we use the law of sines again. To find side C, use your calculator to do the algebra, and so side C is 1.89. Now, what about if two distinct triangles exist? A is acute, in other words, it's less than 90, and H is equal to B times the sine of A. How do we find the two values for A? Maybe angle B can have two different sizes. So let's give it a try here. A is 25.07. It's acute. H is 22 times the sine of 25.07, which is 9.32. 9.32 is less than 9.5, is less than 22, so two triangles. 9.5 is to the sine of 25.07, as 22 is to the sine of B. Sine of B is 0.9813, so B can equal 78.89. If that's the case, then we subtract those two from 180, and C is 76.04, and we'll take time here to find the third side when we have angle B being 78.89. Now, here's the tricky part: how to find the other B. Well, we take our 78.89 and we subtract it from 180. All right, and we get the second B, which then gives us a C of 53.82, and we go through this process again of using the law of sines. You should be pretty good with it now. Side C is 18.1.